Hey guys, in this video we will be going over the quadratic formula. So we've already gone over how we can solve equations of the following form by factoring, completing the square, and using the square root property. Another method for solving quadratic equations is using the following formula, where a, b, and c are real numbers and a is not equal to 0. This formula gives us the solutions for x, and we call this formula the quadratic formula. This formula is very important and will be used often throughout your math education, so it should be memorized. Also, in order to correctly identify what a, b, and c are, it is helpful to write the equation in standard form first as ax squared plus bx plus c equals 0. The following examples are all written in standard form, and we can easily identify what a, b, and c are. Okay, so now let's try solving some quadratic equations by using the quadratic formula. Now, normally when solving quadratic equations, we can always check to see if it's solvable by factoring. However, this polynomial is not factorable. Then we should just try other methods, like completing the square or using the quadratic formula. We will just be using the quadratic formula for this section. So since this equation is already in standard form, we can easily identify the values for a, b, and c. A is 3, b is 1, and c is -3. We plug these values into the formula and simplify to get our solutions for x. And now that we simplified, our solutions for x are -1 plus square root 37 over 6, or -1 minus square root 37 over 6, which is the same as -1 plus or minus square root 37 over 6. To solve the next example, first let's get the quadratic equation in standard form, and now we can easily identify the values for a, b, and c in order to use the quadratic formula. So a is equal to 1, b is equal to -10, and c is equal to 29. And we plug these values into the quadratic formula, and then we simplify to get our solutions for x. It looks like our solutions will be a complex number since we have a negative radicand under the square root. The square root of -16 simplifies to 4 times I. So we have x equals 10 plus or minus 4i all over 2, which can be further simplified by separating this into 2 fractions and reducing. And now our solutions for x are 5 plus 2i, or 5 minus 2i, which is the same as 5 plus or minus 2i. For the next example, again, let's first get this into standard form, and now we can identify the values for a, b, and c. A is equal to 1/2, b is equal to -1, and c is equal to -2. However, if we don't want to work with this fraction for a, we can always get rid of it by multiplying both sides of the equation by the LCD. And now that we've eliminated the fraction, our values for a, b, and c are 1, -2, and -4. This will still give us the same answers for x, regardless if we use the original values with the fraction. So we plug these values into the quadratic formula and simplify. Square root of 20 simplifies to 2 times radical 5. And then we can split these up into 2 fractions and reduce. So our solutions for x are 1 plus or minus square root 5. So equations in various forms may also be solved using the quadratic formula. For this example, we're going to need to first get this equation into standard form to easily identify what a, b, and c are to use our quadratic formula. So we simplify the left side, and then we subtract 3x and add 5 to both sides of the equation. And now that we have our equation in standard form, we can easily identify what a, b, and c are. So a is 9, b is 6, and c is 1. We plug these values into the quadratic formula, and then we simplify. The square root of 0 is just 0, so we're actually going to have one solution for x, and simplifying the fraction gives us -1/3 as our solution.